All right. So our second presenter is Anjanette Steer. She's an ecologist also with the UAA Alaska Center for Conservation Science. So Anjanette will be speaking about mapping riparian habitat in the Montana and Meadow Creek watersheds. So Anjanette, please teach us about this pilot project and how the information will be used.
Thanks, Laura. Just want to verify that you can see my screen okay.
So we're seeing there we go.
Slide.
We got it.
Start with the first slide. How about that? Hold on a second. Good.
Looks great.
Thank you, Laura, for the introduction. And I also want to say thank you to the Mat-Su Salmon Habitat Partnership for the funding that Marcus and I received for the research that we did within the Montana and the Meadow Creek watersheds. So today I'm going to give you a summary of that project and we're wrapping this up for the partnership, hopefully done by end of December, January. But specifically, I'm going to detail the project outcomes and expected deliverables from our mapping of these two corridors. But before I get started, I want to just take one moment for you to think about your most memorable salmon stream experience in South Central Alaska. So mine is standing in the waters of the Fish Lake system, which is on the west side of the Susitna, watching spawning salmon dart around me. And I think we all have reasons why we care about healthy ecosystems for salmon. And my experiences here in the Mat-Su Basin has led me to pursue the scientific understanding of the ecology behind intact salmon watersheds and the wetlands that support them. And I've lived here in the Mat-Su Basin for the better part of 45 years, and I've seen the change firsthand in the productivity of our salmon streams. And so I really appreciate everyone's work with this partnership and enjoyed hearing Becky's talk. We work in the same hall, but we hardly see each other, of course. And so to give you a brief orientation of where we worked, it's Marcus Geis, my colleague, and I, and that's first Meadow Creek. So we're in the core area here, moving west from Wasilla. You see Meadow Creek flowing mainly through the flatlands and lakes. The red is showing impermeable surfaces. So this could be roads, structures. Much of this watershed is road accessible. In contrast, we have the Montana Creek watershed. So if you're driving up the Parks Highway, you come to the Talkeetna Y, and Montana Creek is off to the east here. And it's a mountain-fed stream system with snow melt and has three main branches up here. But as you can see, there's not a lot of red, meaning there's not a lot of infrastructure or impermeable surfaces. So for different reasons, these systems are different, and that's why we picked those to start off this riparian mapping project, because it is a pilot project. So before I talk about our methods, I just want to talk about this concept of riparian. What's a riparian zone, riparian corridor? You hear all these terms. Well, it's a transition between the aquatic world of a stream, like you see here on the left, and then the terrestrial environment of a wetland or an upland. And riparian zones don't typically hold water as long as a wetland, because you can imagine if it's associated with a creek, there is some degree of topographic relief. And the Fish and Wildlife Service has a particular definition for a riparian corridor, and it's going to have one or both of these following characteristics that I'll read here. It's first one being distinctly different vegetation species than adjacent areas, or vegetation species similar to adjacent areas, but exhibiting more vigorous or robust growth. So this was a definition I kept in mind as I was trying to identify the boundaries of the riparian corridors for these two systems. So some of the most recognizable functions and values habitat is shown by this little sign on the little Meadow Creek, groundwater recharge. Hold on a second, I'm trying to go forward on my slides. There we go. Yeah, so other functions. I mentioned groundwater recharge, wildlife habitat, and nutrient cycling. Now, peatlands in particular, these large expanses you can see in the upper left of the photo and kind of on the right side there, have been shown to provide up to 50% of the base flow to salmon streams in South Central Alaska. This is important work that Mike Rotz did and published in 2015. So it gave us some local research showing how important that connectivity is, you know, the water connectivity, the hydrologic connectivity of these wetlands to the riparian corridors, especially when you have those warmer, you know, temperature summers. So alteration of the landscape to affect these connections has been shown to, of course, alter the patterns of the delivery of the water, the nutrients, and organic matter to the streams. And so while it seems like our the research available in South Central Alaska, in particular that related to riparian corridors, is limited, the ecological value, of course, of the riparian corridor is no less significant. And in fact, we have an opportunity with our knowledge of existing resources to identify these riparian corridors and also the connections, right, to the adjacent wetlands, while we still know that we have to have sustainable development in the Mat-Su borough. So our project goals, first, to map the riparian habitat. So we wanted to capture the extent of those areas that are adjacent to the stream or creek that either visually appear to have an important ecological contribution to the stream by change in vegetation or have a visible hydrologic connection. And from that mapping, we wanted to provide a compiled geospatial database to help prioritize riparian habitat conservation. And so we wanted to be able to have the ability, based on what we knew, to look for where the most important habitats were for salmon in the watershed. And so essentially the goal was to take completed research from the bookshelf and bring it into the digital world such that the information could be on the desktop screens of area-wide natural resource managers and planners. And while we were doing that, we wanted to document our methods and just make it a durable method that could be repeated for other watersheds in the Fort area. So those are our project goals. How did we do this? Well, we used imagery. This was super helpful to have current imagery that the Mat-Su borough had acquired. We used LiDAR, we used hillshade relief, and all of these were super helpful to allow me to do like a heads up digitizing effort at a 1 to 2,000 or 1 to 3,000 scale. So I'm just going to show you some pictures of what that looks like. On the left, this is an aerial photo. On the right is with some hillshade. So it just gives you a little bit more idea of some of the relief that you can't necessarily see on the left-hand side without identifying some of those slopes. And here's another picture of another data set that was important to us was elevation. And so I was able to look at the stream corridor and just think about, okay, what that water level, if it's coming up 2 feet, how far out is it going to come? Is that going to affect, and is it affecting the type of vegetation that's growing there? So this to me was the best supplemental resource, if you will, that I haven't been able to use before for doing this sort of wetland or riparian mapping. And so I found this to be super helpful. All right, so some brief slides of our results. This is just a simple slide showing a corridor that's defined. This is on the Montana Creek watershed, but I wanted to show this with the color infrared photography, because it really kind of, to me, shows the point of, okay, the color infrared photography is great for wetlands, and it kind of can pick out the wetlands in the upper right or upper left here in this expanses connecting to this riparian corridor, but it doesn't necessarily pick out the riparian corridor as wet. And so that's just something to keep in mind. The riparian corridor has different functions, and it's not necessarily always a jurisdictional wetland. So more results. This shows in the bottom section what's been mapped by FEMA. It's a flood zone A. You can see it kind of as a white outlined floodplain on the lower part of Montana Creek. And then the upper part shows the work that we did. Well, it's easy to think, that this is super helpful for understanding how the creek floods, which if we walk through the years, we can see that firsthand with historic aerial photography. So this is Kalispell Drive, just east of the Talkeetna Spur. So 1979, then we go to 83. And then to 2020, and I have a summary slide that'll show you this, show a little bit better, different FAWEGs. So we have over 260 meters that this floodplain is kind of wandering back, the river FAWEG is wandering back and forth within between 1952 and present day. So pretty substantial channel migration. What I think is interesting is you can also see the infrastructure that's within this flood zone. So what we hope, our work can do, which I'm going to focus on this upper red box, and that is to show that there's actually other areas outside of this defined flood zone that are pretty important riparian habitat in the sense that they're wide expanses of wetlands and floodplains that are wider than our Mat-Su Borough 75-foot ordinance. So look at the scale at the bottom of the screen and then look at this width here, for example, in that red box, it's well over 150 meters probably. So just something to think about as we, take the challenge of how do we best manage our high habitat to support salmon health. So in the lower part of the flood zone, about 1,800 acres of riparian habitat, if you consider all the flood zone riparian habitat. And then what we delineated in the upper part, that yellow is about 1,268 acres. So a substantial amount of riparian habitat is up above the Yoder Road area. So switching gears to Meadow Creek, which is shown here in the white, the watershed is outlined there. What Marcus likes to call salmon infrastructure. So this is kind of a key component of what we did in this project, and that was to take what we had as geospatial information, starting at the top. For example, we had anadromous water lines on the map for Meadow Creek, but then also add in things that we didn't have. And so cold water inputs, and that's the middle slide showing like the purple dot just is indicator of a larger temperature difference. And then finally at the bottom, the salmon spawning enclaves. So some work the Fish and Wildlife Service did to understand where and document where salmon were spawning. Marcus took that information and made it into a shapefile so that we could take it to a much more detailed level if desired and work at a desktop level. So I'm just going to flip back. So you go from kind of an overview and not all together in an organized manner to putting all this data together where you have infrastructure, you have the thermal regimes, you have the riparian corridor, you have maybe a 75-foot setback. I mean, there's a gazillion things you could add in here, but making that transition from a publication, something on, the bookshelf to this digital world is really the essence of what we've completed for this project. So this just gives you an idea of what we did in that sense. Of project documents were taken then into a geospatial data form. And so this will be, like a jump drive or, some web access that managers, natural resource managers can have to use in the desktop environment of their choice, whether it's ArcGIS, ArcPro, Google Maps, Google Earth, that kind of thing. So. And then this is just one of my final slides about the Parks Highway here is under construction at Meadow Creek. And we know as development in the core area continues, it can have an impact on the riparian aquatic habitat. And as we continue to develop the needed infrastructure, we felt that taking the information, as I mentioned, and taking it from those reports and then putting them into a database is super important to have it accessible. And is an important and appropriate, role for us to do as researchers. And we hope to offer, future assistance to managing agencies when it comes time to actually ranking riparian habitat, because different managers have different purviews. So we didn't feel like it was really our place to do the actual ranking. But the mapping is nearly complete, and I think we can all agree that those wetlands adjacent to the flowing water are the highest priority for conservation due to that connectivity to our salmon streams. And just going back to what John said, it sure is a heck of a lot easier to keep the salmon in the stream and keep salmon in mind when we're developing our needed infrastructure than having to go back and spend millions of dollars to reconstruct the streams after construction. So with that, I'm going to put my project contact information up here. Please feel free to email, reach out if you have questions. I'm happy to take those now.
Excellent presentation, Anjanette. Thank you so much. We have time for one or two quick questions while people type those into the chat box. I'll just ask you, Anjanette, once this project is complete, where is this information going to be stored, or how can people access it?
So we're going to provide this to the partnership, and we'll just come up with a way to either, it depends on how Marcus and I package it, but I mentioned just a simple jump drive to keep it easy, then everything is linked all together there. We may have a way to have a download from the partnership's webpage. So.
Great, thank you. I don't see any questions at this time. So thank you again. And if there are questions that people think about, please just go ahead and put them in the chat box. If there's time at the end, we'll wrap back around. Thanks, Anjanette.
Thank you.